Okay, good day everyone. Today we are going to be going through a brief presentation on everything I've learned so far. So we'll start with a tour of Google Cloud hands-on lab. Okay. Google Cloud is a suite of cloud services hosted on Google's infrastructure from compute resources, storage, APIs, and many more, which can be integrated with their cloud computing applications hosted on their infrastructure. Now, we have Google Cloud Skill Boost. This is where you can access Google Cloud by getting hands-on practice with Cloud Console. This that looks with the Cloud Skill Boost, you get access to labs and courses. The Cloud Console is a browser user interface UI that lets you access and manage Google Cloud services. And this is an overview of how it looks. We have project info, building, error reporting, and stuff. Now the lab fundamentals, features, and components. So in your lab, you have main features are the start button, credit, time, and score. And the start button initializes your temporary lab. The credit is the cost for the lab. Some labs require payment, some are free. The time is the amount of time allocated to you to finish the lab, after which it will be closed and your data in the lab will be deleted. And the score is more like an activity tracking stuff. So it keeps record of everything you've done and gives you score based on your work. So this diagram, you have the start lab button and the top. 1 credit price for the lab. You have 40 minutes the time allocated to it. And this you can't see very well here, but there's something here that's the score. Now Google Cloud Projects. Now it's an organizing entity for your cloud resources. Here you have your project name, your project ID, which is globally unique, and your project number, which is also globally unique. Only the project name can be immutable. So moving on, preparing for a professional cloud architect journey. Now the role of a cloud architect, what are these roles? He enables organizations to leverage Google Cloud technologies, gives them the advantage to he gives them the opportunity to take advantage of Google Cloud's various services and resources to improve their business. And through a solid understanding of solution architecture and cloud computing, he designs, develops, and manages robust, secure, highly available, scalable, and cost-optimized solutions to drive business objectives. So, skills of a cloud architect, enterprise cloud strategy, meaning you should be able to scale cloud computing resources up and down as and when needed in response to fluctuations while still aiming at achieving the business goals. And we have solution design. You should be able to accurately and efficiently define and design applications and software that serve as solutions to business and technical problems. And then we have architectural best practices, scalability, reliability, communication skills, cost optimization, resource optimization. You should be able to manipulate and assess those. Now moving on to Google Cloud fundamentals, core infrastructure. Google Cloud offers compute, storage, big data, machine learning, and application services for web, mobile, analytic, and data storage. So the cloud is a big topic these days, but what exactly is it? So cloud computing is a term that was established by the United States the US Institute for Standard and Technology, but it's not US specific. Cloud computing is a way of using information technology that has these 5 equally important traits. Customers get computing resources that are on-demand and self-service. The customers get the processing power, storage, and network they need to access their resources without the need for human intervention. Customers get access to those resources over the internet from anywhere they have a connection. And the provider has a big pool of these resources and it allocates them to users out of that pool. This allows them to buy the resources, to get the resources in bulk and pass on savings to the customers. And the customers don't need to know or care about the exact physical location of these resources. Resources are elastic, which means they are flexible so customers can be. If you want more resources, you can get more and quickly, and if you want less, you can easily scale back. And lastly, customers pay only for what they use or reserve as they go, which means if you stop using resources, you stop paying. But why are cloud models so compelling these days? To understand that, we have to go through a little history. Now, the trend towards cloud computing began with a first wave known as colocation. Colocation gave users the ability to rent out physical space without having to invest in data center real estate. Now, before colocation came into place, normally when companies or organizations require data centers, they have to establish their own, which costs a lot of money, or they invest in data center real estate. They could rent out physical space back then, but at the cost of you losing full ownership of your organization, or I say organization, sorry. You losing full ownership of your resources. But with colocation, you can rent out physical space in data centers and still have full control of your computing resources. And the second wave was virtualized data centers. Virtualized data centers share similarities with the private data centers in colocation facilities of decade past. The components of virtual centers are similar to the building blocks of hosted computing, like your GPUs, memory, and rest, but now they are virtualized. Now, Google felt like they were not moving at the pace they wanted with virtual data centers, so they introduced a third way of cloud computing, which is the container-based architecture. The container-based architecture is a fully automated and elastic cloud model that consists of a combination of automated services and scalable data. Now, virtualized data center was good, but the infrastructure was still user-controlled and user-managed, but with container-based architecture, it automatically configures your infrastructure for you. Now, Google believes that in the future, every company will distinguish itself from its competitors with the use of technology. And this technology is in the form of software technology, which requires data. So the better your data, the better your technology, the better your organization. And that means, in other words, Google believes that in the future, every company will become a data company. Now, the move towards cloud computing introduced two new services: IaaS, which is infrastructure as a service, and PaaS, which is platform as a service. Now, IaaS offerings provides raw compute, storage, and network capabilities that are organized. IaaS offerings provides raw compute, storage, and network capabilities organized virtually to resources that are similar to physical data centers, provide you with your hardware and everything needed to run your software. But you have to create the software yourself and still user manage. By PaaS offerings, buying codes to libraries that provide access to the infrastructure that the application needs. So PaaS offers everything that IaaS offers and more. PaaS, you don't have to worry about your infrastructure. It gives you the platform, gives you libraries, everything you need to code and run your program. All you have to do is focus on coding your application. IaaS model, you pay for what you get ahead of time.
Let's continue.
Okay, with the IaaS model, you pay for what you allocate ahead of time. But the PaaS model uses a pay-as-you-go type of service, like when you're buying airtime on your phone or transport service, pay as you go. Now, as cloud computing has evolved, the momentum has shifted towards managed infrastructure and managed services. Leveraging managed infrastructure and managed services allow companies and organizations to spend more focus on their business goals and less time and money on their technical infrastructure. This allows them to deliver services to their customers more quickly and reliably. Now, serverless computing is yet another step in the evolution of cloud computing. It allows developers to focus more on their code and spend less time on their server configuration and technical infrastructure. An example is Cloud Run, which allows users to run containerized applications on Google Cloud. Now, software as a service. This provides applications that customers access and use. And these applications are not installed locally on a mobile phone, they are used over the internet directly. An example is your Google Maps. An example is your Google Maps, your email, and almost all Google apps are software as a service. Now moving on to compute engine pricing and billing structure. And for the usage of virtual machines, compute engine build by the second with a 1 minute minimum. Simply means that you are only billed for the time your virtual machine or compute engine instances are running. So that every second they are running, you are billed for every second they run. And with a 1 minute minimum means even if you run it for less than a minute, let's say 31 seconds, you'll be billed for 1 minute. So an example is if you run your virtual machines for 31 seconds, you'll be billed for 1 minute. But if you run it for 2 minutes, 15 seconds, you'll be billed for 2 minutes, 15 seconds. Now there are certain discounts that are offered by Compute Engine. First, we have sustained use discounts, committed use discounts, and printable and spot VMs. And sustained use discounts, they automatically activate from the moment you start running your VMs. So when you are running a VM, if you run it for a considerable amount of time, let's say more than 25% of the month, you run that particular VM, a discount is automatically added for every extra minute you run that VM. And committed use discounts. With committed use discounts, you are offered to purchase a particular virtual machine on the condition that you use it for a specified amount of time, usually 1 to 3 years. And if you agree to that contract, that agreement, you get a virtual machine at a discounted price. And printable and spot VMs. Imagine having to work on a lot of data and not being there physically to supervise. So that's what printable and spot VMs give. Apart from the fact that they are cheaper than your usual virtual machines, they are used to run batch processes like big loads of data, and it's very fast and reliable. Now the printable or spot VMs printable/spot VM is different from normal compute engine with only one respect. That compute engine can be terminated when the resources are needed elsewhere, but with printable/spot VM, it cannot. Compute engine doesn't require a particular option on machine type to get high throughput between processing and persistent disk, which means there's no particular virtual machine or compute engine instance that you have to purchase. Every compute engine offers these services. It just depends on your preferences. Like we have the standard compute engine, which is predefined type of compute engine, and the custom, which you configure by yourself. Finally, you only pay for what you need with custom machine types. Like I said, you can choose your machine properties by using a set of predefined machine types, e.g. an example is your E2 standard machine type. Let's say E2 standard 8 machine type, which offers 8 virtual CPUs and 32 gig RAM of memory. Or you can create your own custom machine type to configure the amount of virtual CPU and memory that you need based on your own preferences. So let's move on to virtual machines and networks in the cloud. Now, when most users start with Google Cloud, they like to set their own VPC, like virtual private cloud, like to set their own VPC configurations, while some just use default VPC. And the ones that set VPC configurations called custom virtual private cloud, while the other is default virtual private cloud. So what's a virtual private cloud? A virtual private cloud is a secure individual private cloud computing model hosted within a public cloud. So it's like, for example, you have your Google Cloud, a public cloud infrastructure. An organization decides to logically isolate a part of that cloud to run their own computing resources. Privately. So virtual private cloud is different from your With virtual private cloud, you can run code, store data, host websites, and anything else that can be done in an ordinary private cloud. The virtual private cloud is hosted remotely by a public cloud provider. Now, the virtual private cloud is different from your normal private cloud. Normal private cloud is like a cloud computing environment solely owned by an organization to run only its resources. But with a virtual private cloud, it's in a third-party cloud provider, a public cloud. You're only taking a part of it to run your resources. It's usually done off premises, while private cloud is on premises, like within the company's facilities. And VPC network connects Google resources to each other and to the internet. This includes segmenting networks, using firewalls to restrict access to instances, and creating static routes to forward traffic to specific destinations using your routers. And Google VPC networks also are global and can have subnets, which are segmented by like smaller pieces of a larger network in any Google cloud region worldwide. So your subnets can span all the zones that make up a region. This type of architecture allows you to easily define your network layout. So the size of a subnet can be increased by expanding the range of IP addresses allocated to it, and this doesn't affect the already configured VMs in that network. So we have an example. We have a virtual private cloud designated VPC1, and you have two subnets. In the first one in Asia East 1 region, and the second one in US East 1 region. Now you decide to deploy three VMs, in these regions. Now these VMs are automatically neighbors. Although they don't share the same subnet, but because they are under the same virtual private cloud, they are regarded as neighbors and can share resources between themselves and also communicate with each other. Now, when I talked about IaaS solution, I forgot to mention, but Compute Engine is an example of IaaS solution, while App Engine is an example of PaaS solution. So let's look at Compute Engine. With Compute Engines, users can create and run virtual machines on Google infrastructure. Compute Engine allows you to create and deploy virtual machines. There are no upfront investments. Thousands of virtual CPUs can run on a system that is designed to be fast and offer consistent performance. So you can have one server with multiple virtual CPUs in there, and each of the CPUs can contain the power and functionality of a full-fledged operating system. Like, unlike containers, which I'll talk about later, virtual servers, you can have a virtual machine, a server with multiple virtual machines, and each of the virtual machines are running on their own operating system. So it contains the power of a full-fledged, one virtual machine contains the power of a full-fledged functional operating system. And lastly, it can be configured much like a physical server. Like you can configure the amount of vCPUs, like virtual CPUs in each VM. You can also configure the amount of memory. Now let's talk about cloud load balancing. Cloud load balancer. Cloud balancer is a Google tool that allows you to manage and control traffic between networks. So this is basically how it works. Users send requests via HTTP or other ways to the internet, and then the cloud load balancer allocates these requests to the various pools of servers in your database. So you can have, let's say, a lot of requests aggregate over 1 minute. The cloud load balancer will distribute this request across the amount of servers that are capable to carry them out. This allows traffic to be balanced in your network. That way your customers receive their results faster. Now the cloud marketplace offers solutions from Google and third-party vendors. So the cloud marketplace is basically a cloud structure where you can get access to libraries and platforms from Google Cloud and third-party cloud providers to run your applications. Most software packages are available at no additional charge beyond the normal fees, except for third-party cloud providers. They can add their own additional charges. And some cloud marketplaces, images charge usage fees, but they all show estimates of their monthly charge before they are launched. So when you want to pay for a service from the cloud marketplace, you are shown like the estimated amount of money you are expected to spend while running that service. So let's move on to Google Cloud storage options. Now, every application needs to store data, be it media that need to be streamed or sensor data on your mobile phone, like when you're setting up your fingerprint security lock. And different applications and different workloads require different storage database solutions. Now, Google Cloud offers 5 core storage solutions for structured, unstructured, transactional, and relational data. And these core storage options are Cloud Storage, Cloud SQL, Spanner, Firestore, and Bigtable. Now, let's go with the first one, Cloud Storage. Cloud Storage is a cloud service that offers developers and IT organizations durable and highly available object storage. Now, what is object storage? Object storage is a data storage architecture that it stores data as objects, not as your usual file or block storage. File storage as in folder hierarchy or block storage and chunks of disk. To better understand this, you have to know what an object is. An object is unstructured data. It's a type of data that doesn't follow any predefined format. An example are your Word documents, images, videos, or audio recordings. And these objects are packaged in a format that contains the binary form of the actual data, metadata, which is like data about the data itself, like the properties such as the size, the author, the time it was created, and so on, and a globally unique identifier. Let's move on to the next one, Cloud SQL. And Cloud SQL is a fully managed relational database system, which includes MySQL, PostgreSQL, and SQL Server. These are all relational database management systems under Cloud SQL. And Cloud SQL is used to offer mundane but necessary and often time-consuming tasks to Google. Tasks such as applying patches and updates to your database software, managing backups, and configuring replications. Next one is Spanner. Spanner is also a fully managed relational database, but this one scales horizontally, is strongly consistent, or you can globally consistent, and speaks SQL. Scaling horizontally simply means you have a virtual machine running a particular workload. If that workload becomes excessive for that virtual machine, scaling horizontally means adding additional nodes, additional virtual machines, and distributing the workload among them. So that's basically scaling horizontally, adding additional nodes and distributing workload among them. While the previous one, Cloud SQL, scales vertically. This means increasing the resources in that particular node. So you have a virtual machine running on a workload, and the workload becomes excessive. Instead of adding additional nodes, you simply increase the components of that virtual machine, like the vCPUs or the memory. Now it is strongly consistent, globally consistent, meaning that people who use Spanner storage option can access the data from anywhere in the globe. And it speaks SQL. SQL stands for Structured Query Language, the programming language used for retrieving and storing data in relational databases. Relational data are simply tabular data, data that is stored in rows and columns. So it's a type of structured data. And Cloud SQL is used for applications that require SQL relational database management systems with joins and secondary indexes. Joins are simply data derived from multiple tables. So you can have table 1 to 4 and table 5. Table 5 collects data from 1 down to 4 and uses it to compose one data. That data is regarded as a join. And secondary indexes help with quick search. Then applications that require built-in high availability, like I said, Spanner is highly available from any global consistency. You can access it from anywhere you are in the globe. And high numbers of input and output operations per second, like thousands of read and write operations per second. Read and write operations are like retrieving data, processing, and storing them. The next we have Firestore. Firestore is a flexible, also horizontally scalable NoSQL database. NoSQL simply means not only SQL. That means it doesn't store data in relational databases. The data in Firestore can be regarded as, to me, it can be regarded as semi-structured because incoming data are stored in documents and then are further organized into collections. Now these the document can be nested data or sub collections. Nested data are simply like object data that comprises of other objects data. Like, let's say you have an information about a person, his name, you have, for instance, Mr. Amin. And then for address, under address, you can have name of the street, name of the city, the address of his house. So those are objects under an already existing object, which is the address of the person. Then we have Bigtable. Bigtable is Google's NoSQL big data database service. Okay, this is like Google's biggest cloud storage option. It's currently what runs most of their services like Google Search, Google Maps, your Gmail. They are used to run semi-structured data that are above 1 terabyte. You can also use them in IoT services and machine learning. It also uses NoSQL. So let's look at introduction to Kubernetes. So what is Kubernetes? Kubernetes is a management platform for containers. So Kubernetes is a Kubernetes engine is a platform that allows you to manage and control containers.
Open source. Open source framework.
Allows you to manage and control containers. So these containers are like invisible boxes that hold the source code and dependencies for your applications. So that way they become durable, highly available, and can be moved without stress. Now, Kubernetes at the highest level can be said to be a set of APIs. So this diagram, you have the kubectl, which is a command in Google Cloud CLI command line interface. You use it to initialize your instructions or requests. So you send requests through HTTP. You send instructions from kubectl using HTTP requests like get, post. So Kubernetes API and gets your results. So the Kubernetes is divided into a set of components which serve as the Kubernetes clusters and a set of nodes which contain containers. Now the Kubernetes cluster is basically just a collection of nodes, and the nodes are like a housing structure for your containers. So let's go into pods. So wrapping like one or more pods together as one container is wrapping one or more containers together for one service is what defines a pod. So a pod is like a combination of various containers for a particular service. Simple terms, let's say you are running an application, a big application, and you want to package you don't want to put everything in one container like front end, back end, and the rest. So you can have everything that you need for your front end. Let's say all the containers you need for your front end in one pod, all the containers you need for your back end, another pod, and then you put this pod in your nodes. And by the way, pods are like the smallest unit of deployment in Kubernetes. So these pods help in such a way that if you have a problem with your backend, for instance, instead of you shutting down the entire thing, like deleting the entire container, you can simply delete just the pod for backend and replace it. That way it won't affect your application drastically. So let's move into Google Kubernetes Engine, or GKE. Now, Google Kubernetes Engine is also used to manage Kubernetes and can run clusters. But Kubernetes can also run clusters. So what is the difference between GKE and Kubernetes? Now, GKE offers automated management of clusters based on your preferences. So with GKE, you don't have to configure much you don't have to configure a lot about your clusters. It's already automatic. But the GKE is divided into two types, autopilot and standard. The autopilot is the one that offers you auto configuration of your clusters. Everything you need to run your nodes and your containers are automatically configured. But with standard mode, it's same thing, but it's user controlled and user configured. So in this image, you have your control plane, your nodes, and connected local services. In the control plane, you have resource controllers, which is used to manage your resources and monitor them. You have the storage, which is used to save your cluster configuration data. And you have the scheduler, which is used to deploy nodes and pods. And to start Kubernetes on a cluster, you initiate this command, gcloud container clusters create K1. Thank you.
So that was a wonderful presentation by Mr. Divine. It was covering the various aspects of cloud architecture. Am I right? Right. So I believe this has been a very insightful lecture. I, for one, have many questions, but I'll invite questions from members of the audience first. So Isaac, what's the question? Structured data.
Structured data is data that follows its predefined format. Like, for instance, you want to store number of people accessing your, let's say you have a web server, and you want to store the data of number of people accessing that web server. So you store them in rows and columns, like the time they accessed it, their API address, and let's say you are running multiple web servers, which one did they access? So it's structured. It has rows and columns. That's structured data. Basically data that has a predefined format.
Alright.
You mentioned that Bigtable stores data that unstructured data that's above 1 terabyte. The ones below 1 terabyte, where are they stored?
You can store data that are below 1 terabyte in Bigtable. But Bigtable was like primarily made to store data above 1 terabyte. Besides, if you store data above and less than 1 terabyte in Bigtable, you are only incurring additional costs. So it's better you go for options that are made for the amount of data you want to store. It depends on the amount of data you want to store.
Can you give him an example of where you store such structured data, but without the consideration for terabytes worth of data?
Cloud SQL is used to store like structured data, but not a very big amount. So that one will be cost optimized for you.
So, your question?
I was asking what subnets are.
Huh?
Subnets.
Okay. Subnets are like smaller pieces of a larger network. Like the simplest one.
So it's virtual private cloud mixes of it. Make use of it.
Yes.
Virtual private cloud mixes of it. Make
Yes.
use of it.
Yes.
How?
You have a virtual private cloud. You want to run multiple VMs on there. VMs.
Virtual machine.
Virtual machines, yes. Each one requires subnet. Okay, let me put it like this. Subnets are regional, not zonal. So you store your VMs in 2 regions. Let's say US is 1 and Asia is 1. Now, those 2 regions where you store your subnets, where you store your VM, they need to have a subnet. But with virtual private cloud, you can expand the subnets by increasing the IP range, the null IP addresses. By increasing the IP range, that way you can deploy more virtual machines in one region. That makes it fail safe, sort of fail safe. You can run the same service, the same resources on all of them. That way, if one should go bad, it doesn't really affect your business.
It also guides against attacks.
Yes.
So if somebody has access to one subnet, you may not have access to the other subnet depending on the firewall rules you set up.
All of them have different addresses.
Good. Please, I'll get another question.
I was asking, you were saying about SQL. I asked a lot about Spanner.
What about Spanner? He's asking in relation to that question about structured data and where to store them. That Spanner is a very good option.
Spanner is a good option, but Spanner is used for when, let's say, you're creating a website and you want the data to be globally consistent, like as a local anywhere in the world, you can use Spanner. But in comparison to Classical, Spanner stores a large amount of data. And the main thing we're looking at here is cost optimization. So you can give me an example of the amount of data I want to store, and I can give you the type of cloud storage that will be best for it.
Okay. I think we can put that to bed here, right?
Spanner stores more
Any
data
other
than Classical.
questions?
Let's talk about Kumba. I don't know how to pronounce the
Kubernetes.
API. Kumbra something.
Kubernetes API.
Yes. What's that about?
No APIs allows different applications to
Communicate.
interact with each other. So Kubernetes has different APIs. We have the pod API. We have containers API. So when you use the kubectl command in GC li command line interface, I'll give you an example. kubectl get ports. The get is your HTTP.
Okay.
So when you initialize that command, kubectl get ports, it communicates with pods API and deploys pods in that node within your cluster. So kubectl command allows you, HTTP request allows your kubectl command to communicate with different APIs, like pod API in the example I gave.
Because the APIs are acting as servers.
No, I think they are a collection of endpoints, right?
Yes,
So you
yes,
specify
that-
your arguments with your kubectl command, which then builds a request that is sent to a specific endpoint, and the endpoint does processes the request as well as the variables that are attached to it to then create and deploy resources of certain configuration.
But you understand the example, right?
So they're not really servers, they're just a collection of scripts that perform various functions depending on the parameters specified, the API itself. Any other question? Okay, thank you very much. Let me ask a question of my own. I think I'll ask this question of Marvelous. So Marvelous, please step up. So we spent a long time talking about cloud architecture, right? So we spent a lot of time talking about architecting solutions on the cloud. What role does this play in connection to machine learning and web development? Where does this sit in that flow chart?
APIs now. APIs, like, as a programmer, I tend to, based on APIs, writing codes to develop websites, you can, like, as a programmer, you tend to work with different tools, basically. So, generally,
Libraries, packages?
their packages. Let's work with several packages which you obviously need to, like, a way for them to communicate with each other. So on API, I would say that we use the knowledge of API to, like, work with those packages for them to, like, be able to, like, perform a certain, for the different packages to be able to perform a certain operation. And also in web development, you need, because clouds now they provide storage and provide storage functions basically. So if you, when developing, like, obviously you need code, you have to, like, store or save your progress steadily as you go, and clouds can help that. My understanding.
Okay, so what about between building AI applications and building